And in this short video, I'm going to show you how to implement the enumerate function in Swift. So first off, the question is, I guess, well, what is the enumerate function in Swift? Well, given a sequence, perhaps say an array of numbers, we can, of course, iterate over these numbers using a for-in loop. All right, so that iterates over each element in the sequence and prints it out. One of the other things we can do is we can use this enumerate function that will basically take the existing sequence A and produce a new sequence that has a zero-based indice for each value in the array. So notice here we've invoked the function enumerate, we've passed in A as its parameter, and so it's taken in a sequence and then produced out a sequence, but the new sequence has this pair, and the pair gives us the indice into the array as well as the value. So that's pretty cool. Question is, well, why would you want to implement it? Looks like it's working perfectly fine. So the reason we probably want to implement it is because it'll give us a view into the world of sequencing generators. So when you want to go off and write your super cool generator that is better than sliced bread, you'll have an idea of how to do that. So first, let's get an idea of kind of what are sequences and generators. Well, as we look at this for loop, right, these for-in loops, they take a sequence, right? And so array happens to live up to the protocol of sequence, and then the return value from enumerate also happens to live up to the protocol of sequence. Well, the sequence protocol just has this one function on it called generate, and generate then passes back another type, which happens to be of generator, which also has one function on it, which is next. So it seems pretty simple at first, but kind of getting through the details of it can be a little bit cumbersome. So let's start here and let's look at how this for loop, let's start with the one with before enumerate. Let's see how this plain old for loop could actually be extracted out just using the sequences and the generator. So instead of actually using the for-in loop, I'm going to use a while loop, but the first thing I need to do is actually get the generator. So like I said, a sequence has a function on it called generate, and the generate function returns to you a generator. And this generator can now be used to basically loop over every element. So notice that the next function on the generator basically returns an optional, and I can use the let syntax to get every value until it returns null and print out that value. So you can think about a for-in loop as producing code similar to what's below here, where you have grabbing the generator from the sequence and then printing the next value each time. All right. So let's go ahead and see if we can generate ourselves our own little enumerate function that does the same thing by creating our personal customized generator and our customized sequence. So the first thing I'm going to do is I'm going to produce the function myEnumerate, which is going to return my new sequence type. Now the myEnumerate function is going to be a generic because I want to wrap any type of sequence and just add the index to it. So the function's parameter is just of sequence type, and the return value is going to be my new sequence type. And this is pretty boilerplate. All it needs to do is just return an instance of my enum sequence. Notice I'm going to have my enum sequence take on initialization the sequence that's passed into my enumerate. All right, so let's go ahead and implement my enumerate sequence. So this is also a generic, and I could have used a class here, but I'm just going to use a struct. And my structure here is going to conform to the sequence type protocol. I'm going to have a property of the sequence that I'm going to wrap. Then I'm going to have the initialization method that's going to take in a sequence and then set my internal property to the sequence passed in. Okay, so now to conform to the sequence type protocol, I must have a generate method. My generate method is not going to just return this generic generator. I need to actually return my new generator type, which I'll create in a moment. So again, this code is pretty simple. For the generate, it's just going to return an instance of my generator. All right, so now we have to go ahead and implement the myGenerator. Notice so far that both the myEnumerate and the myEnum sequence are pretty boilerplate type constructs. So myGenerator is also a generic and conforms to the protocol generator type. So here's where we get to a little bit more code than just the kind of boilerplate wrapping a sequence in a sequence. Here I'm going to actually have to create the value to hold the index and then also hold on to the generator that is passed in. So again, I'll have an init method that assigns my internal generator to the generator passed in the init function. And now in order to conform to the generator type protocol, I need to implement the next method. So the return type for my next method, the element type is going to actually be a tuple, right? It's going to be the two-value parameter that passes back the index as the first element and the value of the internal sequence as the second element. All right, so the code here will basically ask the internal generator, the generator that I'm wrapping, for the next value. If that value exists, it will go ahead and return the current iteration of the index, and if it doesn't exist, it will go ahead and return null. All right, so everything looks almost good. Looks like I have one little error down here where I tried to pass the sequence to my generator when my generator is actually expecting the generator from the sequence. So I just need to fix that by calling generate on this sequence. So now I have my generator, which actually now produces a new type of return value, one that includes an indice and the value of the wrapped sequence. I have my sequence, which is kind of boilerplate, that just kind of wraps the sequence in a new value. And then I have my enumerate, which is also kind of boilerplate, which simply creates a new sequence for me. Let's give it a shot. So I'm going to call my enumerate function, passing in the original sequence, which was the array. And then I'll go ahead and print out what it returns. And sure enough, it's working. Pretty cool. All right, so you can also do, there's a couple of generic types, sequence of and generator of. And I could have done all of this using those two generic types and writing a closure. But I will leave that for another time.